Welcome to the San Joaquin Valley Water and Land Use series on Cali Water Ag. I'm Vicky. In the first 3 parts of this video series, I will go over the Sustainable Groundwater Management Act, or SGMA, the most sweeping new water law in California in a century, which could affect the future of rural communities like yours across the state. It's very important for residents like you to have a say in how local agencies implement this law because their decisions could directly affect you, your water, your job, and what the land looks like around you. This video is the first in a series of videos designed to give you important information about this law and how you can get involved. Part 1.1 will introduce the new groundwater law and its goals toward a resilient California. Before we begin, I'd like to introduce my doctoral work and the motivation for putting together these video series. Hi, I'm Vicky Espinoza and I'm a doctoral candidate at UC Merced. My doctoral research analyzes SGMA's impacts on land use changes and how these land use changes could impact farmers and rural communities like yours in the San Joaquin Valley. My work is founded on the principle that decisions are best made when those who are affected have a say in it. So what am I doing to make sure that your voices are included in future land use decisions? Well, I'm developing a land use model that will inform where and how land could be converted without negatively impacting our communities, farmers, the economy, and the environment. This model includes your voice to ensure that the solutions to SGMA and future land use in the valley are representative of your community's needs and values. I'm also informing and learning from farmers and community members about alternative land uses that could help meet SGMA and benefit communities through workshops and my YouTube channel, Cali Water Ag. I would love for you all to be involved in my work because together we can build solutions for the valley that are equitable and representative of your community's needs. I look forward to meeting you all soon and enjoy the video. In the first part of the Sustainable Groundwater Management Act video series, we will go over why SGMA was passed, what it aims to achieve, and the 6 sins of SGMA to avoid. Now let's get started. You may be wondering, why did SGMA pass? Well, SGMA is a law that aims to bring overdrafted basins to sustainable levels and restore the health of groundwater basins in California. Groundwater plays an important role in the state. California relies on groundwater for about 30% of its water supply in a wet year and almost half of its water supply in a dry year. The map on the left shows total water use in the light blue and use met by groundwater in the darker blue. Although the amount of groundwater reliance is variable throughout the state, you can see that groundwater makes up a portion of the state's water supply, especially for supporting irrigated agriculture in the Central Valley, indicated by the red arrows, which produces about 40% of the nation's fruits, nuts, and vegetables. The graph on the right shows how groundwater has been declining in the Central Valley over the years. SGMA was in part a response to the extreme to exceptional drought we had from 2012 through 2016. In this figure, you can see the progression of the severity of this drought. The most extreme and exceptional drought conditions can be seen during 2014 and 2015, with the darkest red covering a majority of the state. This dry spell was broken by a wet year in 2017. SGMA aims to balance groundwater supply and demand to make sure there is enough water for communities and agriculture for future generations. This map shows priority basins for sustainability plans. Those in dark orange are critically overdrafted and have a slightly different SGMA timeline than those of high, medium, and low priority basins in light orange, yellow, and green respectively. I will go over the SGMA timeline in part 2 of this SGMA video series. Now, what does sustainability mean in terms of SGMA? It means avoiding the 6 undesirable results or the 6 deadly sins of SGMA. What are the 6 sins of SGMA? They are the lowering of water levels of rivers and streams, lowering of groundwater levels, contaminated water, sinking land, reduced groundwater storage, and seawater intrusion. Now let's go over each of these in more detail. Lowering water levels of rivers and streams is of concern during drought years when surface water supplies and water flow in streams diminish. Surface water in rivers and lakes are sometimes connected to groundwater aquifers, and there's an exchange of water. You can think of an aquifer like a sponge made of rock, and the bottom of the sponge does not allow water to pass through, and the water is stored in the voids between the gravel and the rocks. There are 2 types of streams, a water-gaining stream like that shown on the left, where the stream is below the groundwater table, allowing water from the shallow aquifer to supply the stream with water when its water levels are high. A water-losing stream like that on the right is a stream that lies above the groundwater table and loses water when recharging the aquifer. In this case, you can think of the aquifer as a bank account for groundwater. When we have more water going out than coming in, we have a deficit. Rain can help recharge the aquifer water levels as well as artificial recharge by pumping water into the aquifer. Surface water and groundwater have a special relationship in some places in which both are dependent on each other to prevent either one from drying up. Another one of the 6 deadly sins includes avoiding further lowering of groundwater levels by managing the use of groundwater to meet water supplies. On this map, you can see a variety of groundwater wells throughout the state. Those in green show groundwater wells that have seen increases in their water levels, whereas those in orange show a decrease in about 2 to 10 feet of water, and those in red show more than 10 feet of water reductions. Regions reliant on groundwater like the Central Valley are showing large decreases in groundwater levels. A strategy for reducing reliance on groundwater to meet water demand is called in lieu conjunctive water use, meaning using surface water in wet years to allow groundwater aquifers to recharge and using groundwater in dry years. Another method is called active conjunctive use, in which surface water is directly injected into aquifers and wells to be used as needed as part of groundwater banking. Groundwater contamination is a prominent problem in many parts of California, especially in the agricultural regions of the state like the San Joaquin Valley. Some of the major groundwater contaminants in the San Joaquin Valley include nitrates, arsenic, and 1,2,3-trichloropropane or TCP. These can occur naturally and are also byproducts of agriculture, urban, and industrial processes. Salts occur naturally and are byproducts from agriculture, urban, and industrial sectors. All these contaminants impact drinking water, ecosystems, and agriculture. Groundwater contamination has negative implications for many groundwater-dependent communities, like disadvantaged communities. Disadvantaged communities are defined by the state as areas in California which most suffer from a combination of economic, health, and environmental burdens. These burdens include poverty, high unemployment, air and water pollutions, presence of hazardous waste, as well as high incidence of asthma and heart disease. Sinking lands or land subsidence occurs when overpumping of groundwater aquifers causes the land to sink. The photo on the left shows about 5 feet of land sinking that occurred between 1988 to 2013 in the San Joaquin Valley. This number has certainly been increasing over the years. If we take a look at the map of the San Joaquin Valley in the center of the screen, we can understand how much land has sunk recently. Regions in yellow have sunk about 12 to 8 inches. Those in orange about 20 to 16 inches and about 24 to 20 inches of sinking in the red regions. Sinking land can lead to water transport infrastructure damage like canals, pipes, and pumps, like the example shown on the right. On the image at the bottom right, we can see man's best friend with a hydrant that has been exposed due to sinking lands. Sinking lands also leads to the reduction of natural groundwater storage, which is the 5th deadly sin. When groundwater is pumped, the spacing between small soil grains decrease. If the aquifer isn't recharged, these soil grains get close enough to stick together, leading to a reduction in groundwater storage. Once the land collapses and the grains stick together, there is no going back to repair this. Think about it as a bowl of cereal. If you stick a straw in and suck up some milk, the milk levels will drop and the cereal pieces will get close together. The spacing between them will get smaller and smaller until there is no milk left, and all you have left is one lump of many soggy cereal pieces stuck at the bottom of the bowl. And if you try to add milk, the cereal pieces will not separate. And now for the final deadly sin, seawater intrusion. Seawater intrusion is more of a problem for groundwater basins along the coast. Although this isn't a problem for the Central Valley basins, I still want to go over it so that you're aware of other issues present in the state. And maybe you can share this information with a friend who lives or farms in the coastal regions. Seawater is kept out of coastal groundwater basins when there is enough fresh water or sweet water in the aquifer to push out the salt water, like that shown in the figure above. As shown by the figure below, increases in groundwater pumping reduces the amount of sweet water, allowing seawater to enter the aquifer and contaminate the freshwater source. That concludes part 1 of the SGMA video series. Just to recap, we learned that SGMA aims to balance groundwater supply and demand to make sure there is enough water for communities and agriculture for future generations. SGMA aims to avoid the 6 deadly sins, which we went over in some detail. They are lowering water levels of rivers and streams, lowering groundwater levels, contaminated water, sinking land, reduced groundwater storage, and seawater intrusion for our coastal friends. Thank you for tuning in. If you have any questions, please ask in the video comments or feel free to send an email to caliwaterag@gmail.com as seen on that screen. And don't forget to hit that like button, subscribe to Cali Water Ag, and share this video with family and friends so that together we can learn more about California water and agriculture. A special thanks to Vice Lab at UC Merced and the Environmental Defense Fund for funding of this project and editorial support.